Hello, sir.
All
Manish
right.
here.
Yes, Manish.
So, sir, I think these two were the prominent thing we learned in the last one.
Right. So we discussed the logistic regression. Then we discussed the decision tree. And for both the logistic regression machine learning model and decision tree machine learning model, we also looked at the confusion matrix. Now, in today's class, we are going to discuss and also build a random forest machine learning model. So, have you heard of random forest before? What is it? How does it operate?
Yes, sir. Before, during graduation, sir, I learned about it.
So, what is random forest?
So, random forest is an ensemble decision tree model which
Mm-hmm.
take the like decision of various decision tree like by the voting and select the best means classify the best choice.
Right. So, a random forest is an ensemble of decision trees. So, when we are saying, but if it is, let us say, an ensemble, right? So, in decision tree, what we did,
Sir,
you
are you
can see
presenting
the,
something?
I'll share the screen. You can see the screen now.
Yes, sir.
Okay. Now, in decision tree, we looked at the predictor variable. How many predictor variables we have in this data set? Yes, quickly.
So what?
Predictor variables.
16.
Just explain, Pratik, why 15?
The 16. Sir, I think the
Total number of
age.
variables in the data set.
Yes, sir.
Just quickly do STR and tell me total number of variables in the data set.
So there are
18, sir.
18 column, means
Right?
16
18.
variables.
18. One is
18
your
column.
customer ID, right?
Yes, sir.
Then
So
the
we can
other is
eliminate.
your target, and you have 16 predictor variables.
Yes, sir. Yes, sir.
Okay. Now we use these predictor variables to build a decision tree, which helps us classify whether the customer will accept the term deposit or not. Okay, so this is one decision tree and one vote for one particular customer. Okay, so we are using all the predictors. I mean, we are using, initially we built a decision tree model using all the possible predictors. Then we looked at the important variables using the Gini index. And we looked at the most important variables explaining the outcome in the target variable. So those variables, important variables, we looked at and we built a decision tree. Now, when we are talking about random forest, is an ensemble of decision trees. That implies, okay, so you have one decision tree, you have two decision trees, and n decision trees. You have data set here. How many observations we have in the data set? 4521, I
4, 5,
believe.
2, 1. Yes, sir.
4521. We create a subset. Now this subset is with replacement. We create bootstrapped samples. The code itself does this for us. Now, how many decision trees we would like to build, right? In the random forest, we can give that as an output. So number of trees. Now that input we will give in the form of n tree. Okay, number of trees. Now by default, the algorithm takes, if you don't give any input, the number of trees it will build will be 500, which means 500 bootstrapped samples. Okay, now when it is building decision tree, in each case, it will not take all the 16 predictors. Okay, and this also you can give as an output in terms of number of predictors, and this could be 4, this could be 5. What you are trying to do when you are giving this input, let us say if you build a decision tree with balance, age, previous outcome and home loan. You use these x1, x2, x3, x4. Okay, and using these 4 predictors, you build a decision tree, and then you take a vote whether the customer will take term deposit or not. Okay, similarly, you use x5, x7, x9 and x11. Again, some other predictors, similarly x12, x13, 15 and 17. Now the algorithm, it takes randomly, now this input you give, like take 4 predictors, randomly takes 4 predictors, a subset of predictors 500 times, okay, to build 500 decision trees like this. Okay, and after building the decision tree, it takes a vote for each tree. So this tree says 1, this tree will accept term deposit, this tree says 0, this tree says 1, this tree says 1. Okay, so the mode of the outcome is the final vote or final prediction the random forest takes. This is the mechanism behind the random forest. I hope there is a clarity on this. If you have any questions, you can ask. Yes. Now, based on this discussion, can you say which variable is important in this algorithm?
Sir, we can't say because it's selecting randomly, sir.
Right. So it is selecting multiple, though they have devised some. But have you also heard of this black box algorithm? I think I have also used this. But what do you mean by black box algorithm? Yes.
Sir, I think the black box is where the operation is happening, but we don't know about the behind the logic.
Yeah. So you have an input.
Yes, sir.
And you have an output.
Yes, sir.
And if you cannot explain the y element, okay, which variables are explaining the outcome in your output variable or target variable, we are not very sure. you cannot explain the model. You cannot explain the variance in the outcome variable, though you are predicting the outcome accurately. Such algorithms are called as black box algorithm, and even to an extent, random forest is considered as black box algorithm, though what this algorithm tells, when we look at the importance of a variable and calculate the importance of variable, at each decision tree, it calculates which variable is explaining the variance in the outcome variable for each decision tree, and takes the summation of all that 500 decision trees and then gives you, okay, this variable is important and is explaining the variance in the target variable, right? Now, to and that is why number of times, even if with all these sophisticated algorithms, you will see data scientists, analysts, or someone who is building predictive model, okay, they still prefer logistic regression, okay, for building the machine learning algorithm. The reason being, with this you can explain which variables is explaining the variance in the outcome variable, and which variable you need to control, you need to influence, you need to test to so that your outcome variable, okay, you want to ensure that more and more customers accept term deposit, so that you have a higher deposit base, your business grows, okay. So you know, okay, these are the 3-4 variables I need to focus on to increase the acceptance of term deposit, and you can manipulate, test, increase influence and grow your business, right? So so you will find number of times, right, lot of data scientists still telling, okay, we still rely on linear regression and logistic regression. Now this is apart from marketing. Your credit scoring, okay, which is almost equivalent to this problem which we are handling, cross sell, and you have 0 and 1 outcome, okay. As far as RBI regulation is concerned, though companies are using all the algorithms to predict the probability of default of the customers, however, when they are reporting their credit scoring model, okay, they are still using logistic regression to report their credit scoring mechanism to Reserve Bank of India, okay, because other algorithms, they cannot include the explanation in the model, okay. So that's apart from what we are discussing. So let's build the random forest machine learning model. Now, as I have told you, now what from the decision tree, in what ways the formula differs? For decision tree, we used R part. Okay. So for random forest, we use the other formula remains the same. Okay. So run this and tell me what output you are getting. So if you have not installed this random forest package, okay, search this and install the package. I'm posting this package name in the chat box. Search here in the packages, click on install, and then you install this. Okay, run the library command, and then this is just a name. This is the command for building random forest, and this formula. Okay, this remains the same, just the way it was in the decision tree model. See this. Now this model and the model that we are the line command that we are using for random forest, the only difference, this is just a name, okay, and here rather than R part, which is command for building a decision tree, we use random forest, which is a command for random forest. That is the only difference. Okay, so run this command. I am posting the code in the chat box and let me know whether you have done this. Yes.
Sir, I'm getting the error that could not find function random forest.
So install random forest. That's what I told Pratik.
Sir, I did install it.
You run the library command also. Recall the package.
Okay, sir.
Rajat. Rajat, are you there?
Yes, sir.
Rajat, command run किया?
No, sir, my team is not working, but I'm trying, sir. I'm using on mobile phone right now.
Sudhanshu,
Yes, sir.
are you running the command?
Yes, sir.
You're getting the result?
Yes, sir.
Okay. Aman Patel. Aman? Shubham? Now, after running the model, now this is just a name, RFM underscore model. So this is random forest model. Print this model and tell me what output you are getting. So print this, type this command and run this command and tell me what output you are getting.
But it's always the 0 and 1.
Huh.
It's like a confusion matrix with the class error. Hello, sir. Can you hear me?
Yes. Wait, I'll run the command. Right? So in this, see what I wanted to tell you, you're seeing the command output here.
$573, sir.
Right? Now,
Yes, sir.
by default, what this command has done for us, we did not give any output. Okay. So by default, it has built 500 decision trees. And how many variables it has taken? It has taken 4 predictor variables randomly. Out of those 16 predictor variables, right, to build 500 decision trees. Okay, and this is we will look at the confusion matrix for the test data set. Okay, now see, one way is to use this model to predict the outcome for the test data set. Okay, you can very well do that, right? However, and you can look at the accuracy, that becomes your benchmark accuracy. And then what you do, you look at the more important variables, because you would like to build more parsimonious model. You would like to build a model in which you use less number of variables. Okay, and explain the outcome in the target variable. That is also possible. So let's look at the importance of the variables. Okay, so just type RFM model. So this is your name of the model, and in that you also have variable importance. So the command for that is this. So just type this.
Sir, getting the Gini index, sir.
Yeah, right. So which means, so they have calculated the aggregate Gini index, which means which variable is explaining the outcome in the target variable, right? It is equivalent to like an R square in your regression model. Okay, so which variables are important in the model?
Sir, day, then
Day,
duration,
duration,
uh, then the
month,
then customer, sorry, age,
age, okay,
balance,
balance,
job,
job,
P outcome,
P outcome,
and then campaign. Sorry,
campaign,
P days, then campaign.
P days, and then campaign.
Yes, sir.
Right. So yeah, let's run the command. I am copying the command in the chat box.
Sir,
Yes.
sir, can you repeat what we exactly did right now? After getting RFM model importance, we get the Gini
Gini
index.
index.
Then
Yes.
yes, sir. Then we get the R square type the scoring for each variable.
Uh-huh.
Then how did we selected which
No.
one to go for?
So look at this Gini index value.
Yes, sir.
Okay. So the maximum is the duration 157.
Yes, sir.
Okay, so if we use only duration as a variable, probably this will explain at least 60 to 70% of the variance in the target outcome. Right?
Yes, sir.
The moment we drop this variable from our model, probably our accuracy will go down.
Yes, sir.
Okay, so this, based on this Gini index, okay, duration is the most important. Then day is the another important variable. Age, job, balance. Okay,
Okay, sir. Okay, sir. So we are what
then P
threshold
outcome.
we are putting, sir?
Now see, that is again, there is no right and wrong answer for that particular threshold, Prateek.
Yes, sir. Yes, sir. Yes, sir. Like the previously we done. Like
Yes,
in the
yes.
previous examples we done. It's up to us.
Now see, we would probably, let us say this housing loan, housing and loan, these two variables, okay, they are explaining very less variance, okay, their importance in the model is very low, default, okay, we can very well drop these variables when we are building our next random forest model. Okay,
Okay,
so
sir. Okay, sir.
let us say, see, we can, P outcome is 32, and then you can actually plot this also, variable importance plot. We can probably stop at P days and P outcome. That is 22. Okay, now again, the approach is you, the the last variable, the point at which you are stopping, okay, you include that variable in the model, look at the accuracy, and you again drop that variable from the model and you look at the accuracy. If it is adding to the accuracy to your model, probably you will retain the variable. Otherwise, if it is not adding to your accuracy, you can very well drop that variable,
Okay, sir. Okay, sir.
right?
Okay, sir.
Yeah. So till P days is what? P outcome. So you will, Manish, you will tell me the variable till P days, okay?
Yes, sir.
So let us, so what we are doing now, we are building another random forest model,
Yes, sir.
okay? And we are now taking, rather than all the 16 predictor variables, we are taking till
P days, sir.
P
So
days.
it's 9 variable then.
Okay, right? So we will include that. So A from, right from the top, we are taking age, job, we are not taking the marriage status, we are not taking education, we are not taking default, we are taking
Balance.
balance, okay? Then we are not taking housing, we are not
Days.
taking loan, we are not taking contact, we are taking day
Month.
here, okay? Then
Month.
month, okay, month yeah, so month is there. In the end, month we are taking
Duration.
duration, then campaign,
P outcome.
campaign we can drop,
P days and P
Yes, sir.
outcome.
We can drop the campaign.
all right?
P days and then outcome.
P days and then P outcome,
Yes, sir.
right? Now
Yes.
here, okay, you can, the thing, how many trees you want this random forest to build. You can, now generally, by default, this is 500, okay? But you can increase this to 1000, you can increase this to 1500. Ultimately, your objective is to get better prediction and better accuracy, right? So then again, this is like a trial and error. You increase, you decrease the number, you take 1000 trees, you take 500 trees, you, for building that trees, you can give an output, okay, take 5 predictor variables, 6 predictor variables, and build that tree for you. Is that fine? Now this importance equal to 2 implies that you want this importance value that you are calculating in the model. Okay. So this is how you do and build random forest. I'm copying this code. So run this command. So this is your second random forest model. Now what to do next after running this command? Just run this command. and tell me अब आगे क्या करना है.
Sir, same print and we once again see how much is the importance.
So now see, let us say we are accepting this as the final model. So if we are accepting this as our final model, then what we do, we predict the outcome variable from the test data with a new data set. Using the function predict, just the way we have done for the decision tree, you have to copy the code from the top, or you can type. But right, you will use the same code. The only thing is the model changes. Earlier it was decision tree model. Now this is a random forest model based on this model. Model is nothing but an equation, right? It is like y equal to mx plus c. So that equation you use. Based on that equation, again, you calculate whether the customer will accept the term deposit or not. Right? So, see this. Now we are using the same command which we have used in our earlier case, that is decision trees. Now the point I am trying to make is this is getting repetitive in nature. Okay, most of the commands are repetitive in nature, and so the only thing is from one machine learning model to another machine learning model, when you are building a model, it is only the command that changes. Yes, of course, you need to know what is the mechanism behind it and what's happening behind it, but this is how it gets repetitive in nature. Okay, so calculate this classification for random forest using this command. So we are using predict command, which we have used earlier also. This is just a name. We are using the RFM model 2. This is the equation we are telling. Based on this equation, calculate the outcome variable y, whether the customer will accept term deposit or not from the new data set, that is the test data set, and give us the classification in terms of 1 and 0. So this you can, so I'm copying the command. Just reply in the chat box how many of you are doing this. अभी तक जो चल रहा है, you are doing step by step with me. You are running all the commands and you are getting all the outputs. Just post in the chat box. Only 2 responses.
Sir, how are you determining the accuracy of this new model, like RFM model 2? Because in my output, I'm not getting any this matrix also, confusion matrix also.
So you will have to repeat the commands which you used in logistic regression and decision tree. Just ensure that you are using you are just changing the names. I'll explain, Harshvardhan. Yes, sir.
Okay, so the
See
same classification error was.
Yes. See, the most important thing to learn is how do you adapt the codes in a newer context when you have newer variables, when you have newer business problems. Right? Now, if you same we are looking at cross sell and we are looking at outcome 0 1. I am telling you, in practice there are at least all the analytics problems that the world is handling, 30 to 40% of those problems is handled in this way. Binary outcome, like predictive lead scoring, right? In that predictive lead scoring, you have generated lead, you have all the possible data, and you would like to predict which customer will convert and which customer will not convert. Exactly the same approach. Now this IBM customer churn data, which I shared, exactly the same method approach you take and build a customer churn model. Okay, so Harsh, just all the commands that we use in our decision tree and logistic regression model, we'll use the same command. I'll explain that. Okay, so let's move. Okay, now you have this command, submit command from the above. Harsh, you have this command in the earlier when you ran random forest, when you ran decision tree and logistic regression.
Yes, sir.
Right now, the only difference, this is customer ID. You are capturing this from the test data. This is Y actual. You are capturing this from the test data. And this is your Y classification. Now, in earlier case, it was decision tree. This, okay. Now, what you have done, you have calculated Y class using a new algorithm. And you have named that as prediction RFM. Okay, in that case, what you do, you just replace this Y class, this is just the name, and you are assigning these values, okay, to this particular variable. All right, so you run you run this command and see what values you are getting. I'm posting this command in the chat box.
So probability
Sir,
values.
Yes.
sir, actually, I am getting the customer ID Y actual Y class, direct table format, no probability value.
So we are here, we have given the classification, we have asked directly the classification.
Yes, sir.
Okay, in logistic regression, only because of that link function, right? I have explained you that you can ask for probability or you can ask for direct classification value. Now in random
Okay, sir.
forest, we are asking directly the classification value. So then we don't have to use that if else function, provide and assign the cutoff value and everything.
So still I'm getting only these probability values in Y classified.
Share your screen.
Yes, sir. Sir, is it visible?
Yes.
Uh,
Just
so sir, I
view
ran
this.
the same with type
Harshvardhan,
class.
just view prediction underscore RFM value using the command view. Enter there. नया command लिखो. वहाँ enter मार के. Yes, view.
Sir, it's probability values, I guess.
Come back to the earlier command your
सर एक्चुअली इसने दूसरा कमांड कॉपी किया सर। हर्ष
क्या?
जो कमांड इसमें दिया है ना उस वो कॉपी कर दो चैट बॉक्स में, सबसे लास्ट में रहेगा।
प्रेडिक्शन अंडरस्कोर RFM यही वाला
नहीं नहीं, सबसे लास्ट में भी कोड डाला है।
ये जो मॉडल का जो कमांड है ना वो वाला, इसके पहले वाला।
हाँ, सबमिट जो नीचे लिखा हुआ है।
ये
नहीं ये नहीं,
ये
जो सबसे नीचे अभी सबमिट करके लिखा हुआ है ना कमांड, वो वाला। हाँ, उसको
नहीं,
कॉपी
पर
करो, उसको
उसका
रन करो।
मनीष वो हर्ष का जो है ना प्रिडिक्शन आरएफएम वैल्यू, आई जस्ट चेक।
प्रिडिक्शन आरएफएम मॉडल परफेक्ट है सर, सिर्फ सबमिट कमांड में एरर है क्योंकि वो प्रोबेबिलिटी वाला ले रहा है सर, ओल्ड वाला।
ओके, नहीं मनीष, ये प्रिडिक्शन आरएफएम जो वैल्यूज है ना वही गलत आई है कैलकुलेट होकर के।
सर अभी रन करेगा, आई थिंक आ जाएगा क्योंकि उसने केस सेंसिटिव कर लिया है। व्यू करो।
नहीं मनीष, still I'm getting
हाँ
predicted.
हाँ, सो ये आरएफएम मॉडल जो है ना,
Yes sir. Yeah.
आरएफएम मॉडल 2, ये जो कमांड है, दैट कमांड आई एम कॉपिंग। ये हर्ष, ये कमांड कॉपी करके रन करो तुम्हारे आरएफएम मॉडल 2 के जगह पे, उसको डिलीट करो। हाँ, रन दैट कमांड। Now that's fine. Just go to this prediction RFM command. वो पहला वाला रन करो। तो give spaces whenever you are typing the code ना, RFM model 2 इसमें always give space. Make it a habit. ये prediction underscore RFM के आगे जो कमांड लिखा हुआ है ना, predict within bracket RFM model 2 comma space.
Okay sir.
See, sometimes it runs, sometimes it creates problem. Run the command. Again, now view this. Show me, view your train data and test data. Go to the right corner. Just scroll to the right. Okay, show me the test data. Harsh, we will discuss this outside the class.
Okay sir.
Right? Okay, so let's move. So again, right, this is just a command write.csv to create a CSV file. we want to create CSV file using the data frame submit, which we created in the earlier command. This is the name that you would like to give. This is the convention file equals, and the input that you are giving is this tmc rfm.csv included in double quotes, and row names equal to false. This will create a CSV file for you in your project directory. Whatever working directory that you have created, this will create the file for you. Again, this is just a repetition of what we have done in the last class. The only thing is the file name is changing. Run this command and you can go back and look at your project directory. You will find a new CSV file has been created there. Okay, now since we have used the same names, we have kept the same variable names. Okay, and the only thing is we have changed the model and we have recalculated the value. Okay, so then we can very well recycle our command which we used in the context of logistic regression and in the context of decision trees. The only thing that you have to remember is, now since we have run this submit command, the most recent value will be stored in this particular data frame. In logistic regression also we created a data frame named submit. In decision trees also we created a data frame named submit. And yes, and we have created for random forest the same data frame. So जो recent value है, which is your random forest value, will get stored here. Okay, so in that case you don't have to rewrite the command for calculating the confusion matrix. You can recycle that command. See this is the same command we have used here. Okay, this command, and we will be using the same command here. So what we are doing, I'm again explaining that. So we are tabulating the y actual, which is the actual values, and this is the predicted values using random forest. So we are taking a tabulation of the same, right? So we are getting these two values. So the diagonal values are a correct prediction. Then we are assigning that to a particular, we are giving them that as a name, just a name. And then accuracy is sum of the diagonal elements divided by sum of the all elements. That will give you the accuracy of your prediction. So I'm copying this command. Run this command and tell me the accuracy, prediction accuracy that you are getting. You can look at the table also, data frame. So for, let us say, customer ID 2, our prediction is correct. For this also the prediction is correct. For this I'm sharing the screen now. Hello.
Yes, sir. Yes, sir. You are sharing
Okay,
your screen.
right. So now look at this row number 14. Here the prediction is yes. The actual outcome is he has accepted the term deposit, but based on our model, we are saying, okay, this customer will not accept the term deposit. Okay, so this is our wrong prediction. Similarly, this is right. Here again, wrong prediction. So this is how you look at your accuracy of your model. Now, if you want to get into the details, there are at least 17 different parameters: sensitivity, false positive rate, true negative rate. So all those details you get into when you are calculating, when you are evaluating your classification model. So this is about random forest. Now the next algorithm that we will use to predict the outcome, that is whether the customer will accept the offer of term deposit or not. What is the accuracy? Just tell me. What is the accuracy?
Sir, I
So
got
for me,
89%.
Yeah.
how much,
So it is
Manish?
89%.
For
Point.
me, it is
89.11.
90%, 90.20.
yeah. So I am getting around 90. So probably this is a decent outcome. You can also try. That's the reason why. Now, see, using logistic regression, we got some accuracy. Using decision trees, we are getting some accuracy. Using random forest, we have got this 90%. Now, again, we will use support vector machines, calculate the accuracy. Now, one approach is whichever model is giving you the best accuracy, you go with that particular model. Okay. So let's move to support vector machines. Now see this again, when we build support vector machine learning model, the same code we will use. The only thing that we changes is the classification using the support vector machine model. Okay. Now if this was the command for random forest, okay, for support vector machine, the command becomes SVM. Okay, then you assign a formula here.
Sir, any installation or packages required for it?
Yes, I'll explain that, Manish. The SVM package is
Okay,
required.
sir.
Yeah, okay. Now the basic mechanism of how support vector machines operate. Okay, these support vector machines, it actually creates a kind of a classifier or a line, right? Now the simplest line would be a two-dimensional space, right? So we have one dependent variable and we have one independent or predictor variable. The dependent variable is 1, okay, this 1, and this is 0. Now we create a plane, we create a line, a separating line between the two outcomes. Okay, and this is possible when you have one variable. One variable creates a two-dimensional space. Okay, now let us say you add more and more variables. Right, this separating line is called as hyperplane in support vector machines. Now you add more and more variables, okay, and it goes into two-dimensional space, three-dimensional space, four-dimensional space, five-dimensional space, okay, and you call that as your hyperplane. Now the input that you give when you are, now the difference between random forest and your let us say decision tree and other algorithms, here you use for, and see, for random forest decision trees you can use both for regression problems, which is continuous variable, and classification problem, which is your binary outcome. The same thing applies for support vector machines. Okay, you can use support vector machines both for classification problem and your regression problem. So when you are giving input for support vector machines, okay, you type the formula, and when you are saying type, so you give an input, the problem that you are handling, the data that you are handling is your classification problem. Okay, so here the type of the problem is what? Either you use C classification and no classification. Now there is very sophisticated calculation involved. The only thing that you need to understand is dominantly when you are handling classification, the type that you will give as an input when you are building a support vector machine learning algorithm, you will give type as an input, which will be C classification. Okay, and now the calculation of that hyperplane. So on what kernel you are using for that calculating that hyperplane, again there are 4 input that you can give. These 4 inputs are linear, polynomial, radial, sigmoid. Again, very mathematical and statistical calculation at the back end, right? However, in practice, dominantly the kernel as an input that is given is linear for support vector machines, right? So now let's start building our support vector machine learning model on this particular data set. Okay, so the package that is required is E1071. In that package, this algorithm is present. So you need to install E1071 package. If you have already installed, you just run the recall the package, run this particular command. If this command successfully runs, which implies that you have already installed this particular package. Now this is just a name, SVM classifier. Again, the approach, this is just the command support vector machine formula. Now this is optional. Okay, this formula equals, you may choose to write, you may not choose to write. This is optional, right? Formula y tilde, which means you are taking all the variables in your model. You are building the model on the trained data. The type is your C classification, the classification model that you are trying to build, and kernel is linear in nature. So run this command and this will build you a support vector machine learning model. I'm copying this command. So I am copying here. Whenever you are, and this requires practice, practice and practice. The more you practice, the more confident you will get. Always ensure, rather than copying and pasting a command, you type that command. Only then you will realize where you are making mistakes, what problems you are facing, what issues you are facing. So what next? After this?
Sir, the same prediction, then
Yes,
the confusion matrix.
right. Use the predict function Your model is classifier. You're using it for new data. Type equal to class. Remember, we have already given, while building the model, we have told that this is a classification problem. So here you may, if you don't want to type equal to class, you can ignore that. Create the data frame, submit, and just y equal to class, y underscore class. Okay, in that submit wala command, the entire command line, you will replace prediction underscore RFM with prediction underscore SVM and run that command. This will create again, so the same file, because we would like to use the same command. So use the same name. You can rerun the command and you will get the accuracy. Tell me the accuracy that you are getting. Tell me the accuracy that you are getting.
Sir, in this we haven't specified any specific variables, right?
No,
We have
no,
taken
we have.
all the variables.
Yes, yes, yes.
So I'm getting 89%, sir.
Yeah, yeah. So around that number, around 89 to 90 is what you will get, the accuracy.
Sir, 89 for me too.
Yes, yes, right. Yeah. Okay. Abhi, if you are targeting analytics role, ठीक है, for your placements. Now go back to your CV and in your projects, list down this. Now, if you can explain end-to-end R codes of what we have done in the class, only then you will write, right? Project title would be targeted marketing campaign for cross-sell, right? Predicting the acceptance of term deposits of bank customers using R. Is that fine? Hello?
Sir, can you
Yes, sir.
repeat?
So targeted marketing campaign for cross-sell. or cross-selling. Okay, so I'll type that.
So similar steps would be involved if you want to do for churn also,
Exactly. And
because the
you can,
classification.
yeah. And so you will write that also. We will do this. Now we will speed up. For this particular case, we have gone very slow and right, but that we will speed up. So I have posted that in the chat box. In R or using R? Now, are you aware from where I have taken this data set?
Kaggle.
Yes. Okay. So this data set is also available on Kaggle, and this is a very, very popular data set. Okay. Now you can create a profile on Kaggle and post these codes and participate in the competition for this particular data set. That kind of starts building your profile on the Kaggle community. You can do this similarly for that Titanic data set. You can do this for Iris data set. You can do this for IBM customer churn data set. Okay. And there are other algorithms also, but right. So we have, as in the outline I have mentioned, we will be using 4 algorithms and then more and more case studies. So for this particular, see, this is not the final model. Okay, there are other algorithms also which might increase the accuracy. And I'm again repeatedly telling this. In competitions, accuracy matters. Okay, you increase the accuracy of your prediction and you win the competition, all these hackathons. Okay. However, in real life and in practice, accuracy is not so much important, and accuracy is always traded for the explanation part. Okay, you have higher accuracy but no explanation. You cannot answer why customers are accepting term deposits. You cannot provide the reason. Then accuracy is of no use to managers in real life. All right.
Yes, sir.
Yeah. Now I had shared the data, and I had requested all of you to do the exploratory data analysis for the IBM customer churn data, which is in the context of telecom industry. Okay. Now, the first example that we used was from the financial and banking services industry. Okay. Now, there is one more data set, right, for customer churn in the context of banking industry. If you want to work on that, I will share the data. You let me know and I'll share that data also. So, and for that data also, you can build the project. Again, claim that in your CV. Okay, you can build a customer churn in the context of banking industry also. All right. So, so I have received almost the submission, exploratory data analysis submission from almost, I think, 50 to 60% of the class. For the others who have not done, because now we will not get into the detailed aspects of EDM because we don't have time, and I believe for the in the first case example we have spent considerable amount of time. So what you will do, you will create the project, you will set up the working directory, and you will import the data set in R. Okay, that is the basic steps that you will have to do anyways. Okay, and then what I will do, so this is the IBM customer data set. So I have set up the working directory and I am importing the data set. Okay, and what I have done, just to simplify life, and I would like to use the codes which I have used in my earlier data set, in our earlier data set, right? Sorry, in our earlier project. So what I'm doing, I'm using the same name here. So I'm assigning this raw data set and renaming as data set. Okay. So what I will do, I will share these commands. The only new thing about this is there are some missing values in this, and I'll explain that. So see this. अच्छा मैंने वो project close कर दिया ना. Wait. Now, what I am trying to explain is the similarity of approach in our cross-sell model and in this customer churn model. See the steps. Here we are importing the data set. Here also we are importing the data set. Then we are looking, deep diving into the data set by using the structure command head tell. We are also trying to view the data set. Right here the variables are changing. Here also we use the same thing. Now see, I'm using the same command. Right? The next thing is, after you have looked at the structure in the data set, okay, so then you list out, you look at the variables. Gender is a factor, I'm fine with this. Senior citizen is a factor with 2 levels, partner, dependents, again a factor, phone service, again factor, multiple lines, factor, and these are monthly charges, which is numeric, and these are total charges, which is again numeric. Customer churn is factor with 2 levels, customer churn which is 1 and customer did not churn which is 0. Now if you are getting the output as character rather than factor, then you will use this as dot factor command to convert that character variable into factor variable. And then you will repeat the steps for all other variables if it is giving you an output as character in the variable. The same thing we did in cross-sell. We converted, we were getting character as an output. we wanted to convert that variable into factor variable, we use as dot factor. For all the other variable, the same thing we are doing here, as dot factor. Okay, then for categorical data, categorical variable, we tabulated what is the frequency distribution, let us say for gender, right? The same thing we also did in the cross cell. Okay, then for the continuous variable, we calculated the mean and standard deviation. We can also use the command summary. Okay, tenure and monthly charges and total charges. These are the numeric or continuous variable in our data set. Now in the total, I believe in total charges or total charges, there is missing value. I'll explain that. But let me explain all the steps. Probably in the next class, I'll take that up. Right? Similarly, the same thing, we calculated the standard deviation for the continuous variable. In cross-cell model also, we repeated the same steps here. The next step was to do the missing value analysis. Right? This particular variable, we are asking whether there is a missing value or not. Just wait, is dot na, and then we are tabulating these values, and we will get, okay, how many values we have, many values. So here all the values are false. We don't have any missing value in this particular variable. Yes, someone was asking question.
सर एक्चुअली हमने जब पहले समरी किया ना, जब हमने उसका एनालिसिस किया ना डेटा का बेसिक वाला, स्टैंडर्ड डेविएशन एंड मीन लेके, तो सर तभी पता चल जाता है कि मिसिंग वैल्यू है कि नहीं. तो सर बिफोर डूइंग एनालिसिस, इफ इट वोंट इट बी बेटर वी डू मिसिंग वैल्यू analysis first and then do the basic analysis?
Yes, that is fine, Pratik, if you do that. However, let us say आप impute कर रहे हो, mean imputation कर रहे हो, ठीक है, या whatever that you are doing, right? Now before doing this, you calculate the mean with missing values. Okay, and I'll explain that how to do that. Now you, okay, when you run that command, you know there are missing values. Then you find out how many missing values you have. Okay, then you impute the missing values.
Yes,
and
sir.
Our assumption is, after calculation, after imputing mean imputation, the mean doesn't change. Okay, let us say in your class the average age is around 25. Right, now we add 2 more students whose age is 25. The mean of the class will not change, the average age of the class will not change, and that is what is the assumption. Okay, whenever we impute any missing value, we would not like to distort the data or distort the results. When you impute mean, it actually, the objective is you are not losing the data, as also you are not introducing any distortion in your data. Okay, so you impute value and then you recalculate the mean value, just to ensure whatever you have done is correct. Pratik, does that answer your question? Why
yes,
we
sir.
calculate first mean, okay,
Yes, sir.
and then again impute and then recalculate.
Okay, sir.
Right? Some analysts prefer, yeah, Manish, wait. Some analysts prefer even building the model with missing values. Okay, then they impute the values, then again build the model and then see, is there a difference? Is it changing the model entirely? Is it bringing variance in my model? Okay.
Yes, sir.
Yes, Manish, you were asking some question.
Sir, actually, when we try to check the mean, if there is a missing value, then it will not show. It will
I
not
will
going to
explain.
give any report.
Manish, I will explain.
Okay, sir.
Right. Now, yeah. So for everyone, now this is for participants who have not done any EDAs. So I am happy at least 50 to 60% of you have submitted, which means you are getting something, you are doing something. And if you are able to understand the end-to-end cross-sell projects, their codes, their output, what is the method, why are you doing this, right? So that in itself is a huge learning, I believe. And as I said, you can claim this when you are looking for analytics or machine learning placements to so you can target that. But so for participants who have not done, I have copied the entire code of EDA for customer churn project. Okay. नाउ अभी बस इतना ही करना है आपको. आपको प्रोजेक्ट क्रिएट करना है, डेटा इंपोर्ट करना है, ओके, एंड ये कमांड को कॉपी करके यहां पेस्ट कर देना है, एंड लाइन बाय लाइन यू रन द कमांड, you understand the output, you understand what is happening behind. So I hope you guys will do at least that. And then, yes, of course, in the next class, I will explain. We will start with missing values. Okay. And then I will also explain the concept of stacked bar plot to understand the relationship between two categorical variables in this particular, in the context of this data set. But people, right, some of the students, you are continuously reaching out to me with your queries and are practicing for missing value, right? Let us say you are calculating the mean of missing value किस में थे? Total charges में ना? Total charges.
Yes, sir. Yes,
okay.
Sir.
Now, if you run the command, you get an error, right?
सर मीन तो आ जाता है ना, स्टैंडर्ड डेविएशन नहीं आता है ना?
नहीं नहीं, मीन भी नहीं आता है.
नहीं, मीन भी नहीं आता है.
Okay.
Okay.
So you have NA values, which means missing values. Missing values in R is represented by NA values. Okay. ठीक है. So what you do, NA dot RM equal to true. Now what this command implies is the NA values that are there in your data set are missing values, true missing values. If you give this as an input, you and run the command, then it will ignore those missing values. Let us say there are 5,000 observations, 100 missing values. It will calculate mean for 4,900 rows and give you the output of mean. This is how you handle missing values. Now you know missing values using is dot NA in, let us say, this is your data set, this is your NA, this is your NA. Now using the command, you know, okay, this is the missing value, this is the missing value. You ask that, now you give an input ki whatever, wherever there is a missing value, NA value, replace that with mean. You give some value or you assign this code here. This will impute the missing value. So we will discuss this in the next class. Okay?
Okay, sir. सर जीरो भी दे सकते हैं ना सर?
जीरो भी दे सकते हैं, बट
एरर आ जाएगा.
अगेन हाँ, प्रैक्टिस इज टू इंप्यूट मिसिंग वैल्यू. आप जीरो दे देंगे तो उसका मीन डिक्रीज होगा कि इंक्रीज होगा?
डिक्रीज हो जाएगा सर.
राइट. सो दैट इज व्हाई मीन इज प्रेफर्ड.
ओके सर.
फिर तो कैटेगरिकल वेरिएबल के लिए क्या करोगे?
मोड.
Yes. So for categorical variable, you will impute the mode value. All right. So we'll stop here. Do you guys have any additional slot this week so that we can take one class that we missed in the last week?
सर सबके कॉम्बिनेशन अलग हैं, तो पीजीपी को ही बेटर पता होगा सर कि कौन सा
अच्छा,
स्लॉट फ्री है।
ठीक है, all right.
ओके सर।
Yeah, so we'll stop here. The class is formally closed. If you have any questions, I'm here to answer. Okay, so yeah, thank you all for your patience. I am closing the
थैंक यू
class.
सर।
Thank you, sir.
Yes, yes.